Look around you. The chair beneath you, the walls of your room, the street outside, the stars above. You think you see the world, but what you see is less than 5% of it. The rest? Invisible, undetectable, unfelt, and yet it holds everything together. Galaxies spin faster than they should. Stars orbit at impossible speeds. Clusters of galaxies shouldn't exist. Their gravity is too weak to bind them, and still they hold, as if held by invisible hands. For nearly a century, scientists have searched for this unseen force. They've built colossal machines, fired particles at near light speed, buried detectors under mountains, looked into the deepest voids of space, and still nothing. No flash, no signal, no trace, only silence. And yet, we know it's there. Not because we saw it, but because without it, the universe would fall apart. This is not science fiction. This is physics. This is dark matter, and is the most real thing in the cosmos that you will never see. In 1933, an American astronomer named Fritz Zwicky was studying the Coma Cluster, a dense group of over 1,000 galaxies. He measured how fast the galaxies were moving. Using Newton's laws, he calculated how much mass should be needed to keep them from flying apart. The answer? 10 times more than all the visible stars, gas, and dust combined. Something was missing. Something invisible. He called it Dunkel Materie, dark matter. His colleagues laughed. "You're seeing ghosts," they said. "There's no such thing." Back then, telescopes couldn't detect faint objects. Computers didn't exist. No one believed him. For decades, his paper gathered dust, until the 1970s, when another astronomer, Vera Rubin, studied the rotation of spiral galaxies. She found something shocking. Stars on the outer edges of galaxies were moving just as fast as those near the center. According to Newton, they should be slowing down, like a spinning record losing speed. But they weren't. They were racing, as if pulled by something unseen. The only explanation? A massive halo of invisible mass, stretching far beyond the visible edge of the galaxy. Dark matter wasn't a mistake. It was a revelation, and it was everywhere. Dark matter doesn't shine. It doesn't glow. It doesn't reflect light, but it has weight. And weight means gravity, and gravity shapes everything. After the Big Bang, the universe was a hot, dense soup of particles. Normal matter, protons, electrons, photons, bounced around like popcorn. But dark matter? It was slow, cold, silent. It didn't interact with light. So while normal matter was scattered by radiation pressure, dark matter clumped together, slowly, quietly, forming a cosmic web. Threads of invisible mass, filaments stretching across billions of light years. And along these threads, normal matter fell, like rain falling into rivers. Slowly, galaxies formed, stars ignited, planets cooled. Without dark matter's gravitational scaffolding, none of this would have happened. There would be no Milky Way, no Sunday, no Earth, no you. Dark matter didn't make stars, but it made the stage where stars could dance. We don't need to touch dark matter to know it's real. We see its effects everywhere. In galaxy clusters, when light from distant galaxies bends as it passes through a phenomenon called gravitational lensing. The amount of bending is far greater than what visible mass can explain. The extra gravity? Dark matter. In the cosmic microwave background, the oldest light in the universe. Tiny temperature fluctuations match predictions only if dark matter makes up 27% of the total energy content. In simulations of the universe's evolution, without dark matter, galaxies form too late, too few, too messy. With dark matter, perfect, clean, real. We even see it in our own galaxy. The Milky Way's disk rotates faster than it should. Its outer arms are warped, pulled by unseen mass. Dark matter isn't hiding in some far corner of space. It's here, around you, inside you. Right now, millions of dark matter particles are passing through your body every second. You feel nothing. You see nothing. But they're there. Here's the problem. Dark matter doesn't interact with electromagnetic forces. That means no light, no heat, no electricity, no magnetism. It doesn't absorb. It doesn't emit. It doesn't reflect. It only interacts through gravity, and maybe very weakly through the weak nuclear force. That's why we can't see it, and why we can't trap it. On Earth, scientists have built detectors deep underground, shielded from cosmic rays, filled with ultra-pure materials like xenon or germanium, waiting, hoping that one dark matter particle, just one, will bump into an atom and leave a whisper of energy. Decades, billions of collisions, zero signals. At CERN, the Large Hadron Collider smashes protons together at 99.999999% the speed of light. We found the Higgs boson. We've confirmed the Standard Model. But no dark matter particle. Not one. Some say it's a new type of particle, WIMPs, weakly interacting massive particles. Others say it's axions, ultralight quantum ghosts. Maybe it's primordial black holes, or something we haven't imagined. But every theory fails. Every experiment hits silence. The universe hides its greatest secret and refuses to tell us why. Some scientists refuse to believe in dark matter. They say, maybe Newton was wrong. Maybe Einstein missed something. Maybe gravity behaves differently at vast distances. Enter MOND, Modified Newtonian Dynamics. Proposed in 1983 by Mordechai Milgrom, it suggests that gravity doesn't weaken the way we think it does, especially in low-acceleration environments like galaxy edges. And strangely, MOND predicts galactic rotation curves almost perfectly. No dark matter needed. But here's the catch. MOND fails everywhere else. It can't explain gravitational lensing. It can't explain the cosmic microwave background. It can't explain why colliding galaxy clusters show mass separated from visible matter, like in the Bullet Cluster, where dark matter passed through, but gas collided and slowed down. The mass, revealed by lensing, was where there was no gas. No stars, just gravity, with no visible source. MOND can't explain that. Dark matter can. So while MOND is elegant, it's incomplete. And the universe doesn't care about elegance. It cares about truth. Here's the strangest truth of all. You, your body, your thoughts, your dreams are made of atoms. Protons, neutrons, electrons. That's normal matter. And it makes up just 5% of the universe. Dark matter? 27%. The rest? Dark energy pushing space apart. So you're not the majority. You are the minority, the glitch, the accident, the rare spark in a sea of darkness. Everything you love, your family, your music, your sunset, is made of the same stuff that composes less than 1/20th of reality. The rest? Invisible, unseen, but holding you and everything you know together. If dark matter vanished tomorrow, galaxies would fly apart. Stars would drift into silence. Planets would freeze. Life would end, not because it was destroyed, but because the stage collapsed. You are not separate from dark matter. You are a child. Scientists aren't giving up. They're going deeper. Literally. In Italy, under the Grand Sasso Mountain, the Xenon detector waits. A tank of liquid xenon, colder than space, shielded by rock. In Antarctica, the Ice Cube Neutrino Observatory uses a cubic kilometer of ice as a detector, looking for signals from dark matter annihilating in the sun's core. In China, the Jinping Underground Laboratory digs deeper than any other. In space, The Euclid telescope launches to map the distribution of dark matter across 10 billion years of cosmic history. Even neutrinos, ghostly particles that pass through Earth like wind, are being studied as possible dark matter candidates. Every experiment is a prayer. Every null result, a lesson. We're not searching for a needle in a haystack. We're searching for a needle made of silence, inside a haystack made of darkness. What if dark matter is real, but forever out of reach? What if it exists, but interacts so weakly that no detector we can build will ever sense it? What if it's not a particle at all, but a flaw in our understanding of space-time itself? Then we will have to rewrite physics. Not just update it, not just extend it, rewrite it from the ground up. We would have to question everything we thought we knew about time, about space, about mass, about energy. It would be the greatest scientific revolution since Einstein, more profound than relativity, more disruptive than quantum mechanics. Because if dark matter isn't a thing, then what is gravity? Is it force? Or is it geometry? Is it emergent? Is it illusion? We may never know, but we will keep asking. Dark matter doesn't care about us. It doesn't notice our telescopes, our labs, our equations, our dreams. It doesn't want to be found. It just is. And yet, without it, we wouldn't exist. It shaped the first galaxies. It gave birth to the sun. It kept Earth in orbit. It allowed life to form. We are made of stardust, yes, but we are held together by shadow. We are children of the visible, born in the embrace of the invisible. And when you look up at the night sky, you are not looking at stars. You are looking at the surface of a giant iceberg. The stars? Just the tip. The dark matter? The mountain beneath. Vast, silent, eternal. And we, small, fragile, fleeting, stand on its edge, wondering, asking, waiting. Dark matter is not a mystery waiting to be solved. It is a mirror. It shows us how little we know, how small we are, how deeply we are connected to things we cannot perceive. We measure the universe in light years, but dark matter reminds us the true scale of existence is measured in silence, in absence, in the spaces between stars, in the gaps between our questions. We may never find it. We may never name it. We may never hold it in our hands, but we already live inside it. It moves through you. It holds your atoms in place. It keeps your planet from drifting into the void. And when you die, it will remain patient, endless, unseen, still holding the universe together, long after we are gone. We hope this journey ignited your curiosity. Stay with us as we explore the hidden architecture of reality, where the most powerful forces are invisible, the most essential truths are silent, and the greatest mysteries are not out there, but within the fabric of everything you've ever known. Subscribe and join us for the next discovery.